Hey guys, I'm Jade. Welcome to my LeetCode Review One Take vlog on 207th problem, course schedule. There are a total of 9 courses we have to take, labeled from 0 to 9 courses, subject 1. We are given an array prerequisites where prerequisites of I gets AI, BI indicates that we must take course BI first if we want to take course AI. For example, the pair 0 and 1 indicates that to take course 0, we have to first take course 1. We'll return true if we can finish all courses, otherwise we'll return false. And let's see the example 1 here. The num courses is 2 and the prerequisites is 1 and 0. And the output is true because there are a total of 2 courses to take. To take course 1, we should have finished course 0, so it is possible. And let's see example 2 here. We got 2 courses and the prerequisites is 1 and 0 and 0 and 1. The output is false because to take course 1, we should have finished course 0. And to take course 0, we should also have finished course 1. So it is impossible. Now, let's start with the main idea of this problem. Our goal is to check if there's any cycle in this directed graph. If there's a cycle, we can finish all courses. First, we can use that first search with 3 states. Node checking to detect cycles. For example, 0 means unvisited, 1 means visiting, and 2 means visited. If during the that first search we revisit a node that's already been visited, which means we've found a cycle. And instead of the that first search, we can use Kahn's algorithm, which is based on integrate counting and breadth first search traversal. But let's start with the depth first search first. Inside the solution, we start by declaring an array to check each node's visitation state. Let's say private integer array named state. Then we declare our adjacency list to represent the directed graph. Each index represents a course and its value is a list of dependent courses. Private list of integer called graph. Then inside the canFinish method, at first we'll initialize the adjacency list container. Graph gets new array list. Next, we implement a for loop to traverse each course and initialize an empty list of neighbors for each course. Let's say for integer I started at 0 when I is less than num courses. We'll increment I after each iteration. For each course, we add an empty neighbor list so we can store outgoing ages. Graph.add of new array list. Then we create an enhanced for loop to traverse each prerequisite pair in the input array. Let's say for integer array called pre in prerequisite. Inside the loop, we unpack the dependent course and its prerequisites. Let's say integer course gets pre of 0, and the prerequisites called before gets pre of 1. Next, we add a directed edge from before to course into a graph. Graph.get of before dot id of course. Out of the for loop, next we'll initialize the state array to keep track of each node's visitation status. And we'll set all the states to 0, which means all the nodes are unvisited. State gets new integer array, and the length of it is num courses. Now we loop through each course. For integer I started at 0, when I is less than num courses, we increment I. For each iteration, if the course I has not been visited yet, we'll start a depth search for node I to check for cycles. And the code is state of I equals 0. We'll start a depth search for node I to check the cycles. And the code is if has cycle. We'll implement the hasCycle method in the further code. And we need to pass I into the hasCycle method. If a cycle is detected, we immediately return false, which means we can finish all courses. Or if no cycles are found after exploring all the nodes, we'll return true. Return true, which means we can finish all the courses. Then we need to implement the hasCycle helper method to perform a depth search from a given node and return true if a cycle is detected. Private volume called hasCycle. And this method needs a parameter called, let's say, integer u. First, we mark node u as visiting before exploring its neighbors. So state of u gets 1. 1 means we are visiting this node. Then, for each neighbor v of u in the adjacency list, we'll create an enhanced for loop. Integer let's say integer v in graph dot get of u. For each v, we'll check if v is still unvisited or not. And code is if state of v equals 0. If so, we'll recursively call hasCycle method on the node v. If hasCycle of v. If this recursion found a cycle, we'll return true. Return true. Then we'll check if v is already in a visiting state or not. So the code is else if state of v equals 1. If so, we've detected a back edge, which is a cycle. So we'll return true. Return true. Once all neighbors are safe, we mark the node U as visited, and code is state of U gets 2. Finally, we'll return false because no cycles was found starting from node U. The code is return false. Alright, that's all of the code. Let's submit the code and check if our solution passes all the test cases. Absolutely, our code got accepted. Now, let's analyze the time and space complexity. So, the time complexity is come up with several conditions. First, we build the adjacency list, which takes big O of P. P stands for the length of prerequisites. Second, the depth first search visits each node once and traverses each edge once. So this time complexity, it is big O of, let's say, n plus p, where n is the num-courses. Overall, the time complexity, it is big O of n plus p. And for space complexity, first, the adjacency list stores big O of n plus p entries. Big O of n plus p entries. Then, the state array use big O of n space. So the overall space complexity, it is also big O of n plus p. Okay, this is the end of my LeetCode review one-take vlog on this problem. You can also visit my online GitHub page here, which contains all the notes, problem description, codes with very detailed annotations, and the final time and space complexity analysis. And we can also figure out the Khan's algorithm on this page. And you can also visit my GitHub repository here, which contains all the codes and notes to build this online GitHub page. And I'll put those two links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.